A 60 kilogram woman stands on a weighing scale inside an elevator. The elevator accelerates upwards at 0.8 metres per second every second. And we've got to determine the reading on the weighing scales. In other words, we have to find what she sees on those scales when the lift is accelerating. Now, to do that, we must identify the forces acting on the weighing scale themselves. That's the weighing scale represented there, and the first force acting on the weighing scale is indeed the woman's weight, W. And we know that W equals mass times gravity. Now, the other force acting on the weighing scale is the force due to the floor pushing up onto the weighing scale, and that's the normal force, which we call N, like that. And it's this N which is going to give rise to the reading on the weighing scale. Now, if the lift is accelerating upwards, we know that the unbalanced force must equal all the forces adding up the way, which is N, and subtract all the forces acting down the way, which is the weight, which equals mg. So we have unbalanced force equals N minus mg. Now, we also know that the unbalanced force is equal to mass times acceleration. And therefore we can substitute unbalanced force equals mass times acceleration into that top equation to give us ma equals N minus mg. And if we rearrange for N, we get the following expression. The normal force N equals mg plus ma. And it's this normal force which is going to give you rise to the reading on the weighing scale. Now, you won't get that equation or that expression in your relationship sheet. You have to either remember it or you have to derive it from that little diagram there. It doesn't take much to derive it. And it's also good to derive it because it gives you a good understanding of the forces acting on that weighing scale. So if we work out what N is, it's a straightforward little substitution. The normal force N equals bracket the mass 60 times 9.8 plus the acceleration mass 60 again times the acceleration upwards, which is 0.8. And if we do that in our calculators, we end up with N equal to 636 newtons. So that's going to be the reading on the scale because that's the normal force acting on the actual weighing scale itself. So that's a good method of working out the famous lift equation in the higher physics exam.